So in this error log, what you have is a way to log all your, silly mistakes, big mistakes, and everything. Basically, whenever you make a mistake, you identify the type of problem you made a mistake on. So if it's a linear inequalities question, you put that. Then you say, the mistake you made. So it might be, the very common mistake. When you expand the brackets, you forgot to, let the negative affect every single term. This is a very common mistake that, everyone has made. I think everyone here has made it, right? And, you know what the mistake is, but you still make it because it's a habit, right? So that's where this error log comes in to break that habit. First thing about this is identifying the mistake, right? Then you write down the correct thing you should have done, which is to distribute the negative over every single term in the bracket, right? Actually, this might be useless, honestly. Oh, no. This is kind of useless. Ignore the key learning. I've thought about it. I need to get rid of that on the new template. I think the next important thing is next steps, which is what are you going to do to fix it?
Create a drill. Do you have to create a drill?
You can come up with something on your own. But, this is an example one. Quick, it doesn't have to be 5, maybe 2 or 3, right? Where you just go literally write basic drills and you drill it into your mind. You're not going to make this mistake again. Because each time you have to do a drill, right? And I want to see all of you do it. Because the thing is, in the problem session we do at the end of the lesson, it's not about how many questions you answer, right? It's about how much you learn. And by doing the error log, you identify your mistakes. That is learning, right? I saw a few people on the post last week. This is a very, very common misconception. So don't think, this is a really bad way to think. Is a lot of people said, next week I want to learn everything about this before I attempt a question. It's very hard to do, right? It sounds good in theory, right? It sounds good in theory. I thought of that. I was like, oh, let me just learn it properly, then do it. No, learning works because our brain can't handle a lot of information at once. Our brain's only meant to handle 3 to 4 things at once. It can go up to 7, but that's really working at peak capacity. You don't want to work at peak capacity all the time. So really, on average, about 3 to 4 things at a time. And so that means you can't learn every single nuanced detail, right? So you just learn the basics. You try the question, then you learn from your mistake, right? And then when you learn from the mistake, you sort of slowly add on. You learn the first 3, 4 things, then you make the mistake and you learn the 5th thing. Make another mistake, learn the 6th thing, slowly add on and add on, right? It's called stacking. You want to stack your gains, right? You don't want to try to learn all 9 things at once and then all of a sudden you're like, okay, which one of these am I going to do? It's hard. It's better to just learn the basics and then learn through mistakes. That's where this error log comes in, right? So I want you guys to get over this misconception of trying to learn everything at once because it's just not feasible, right? Like when I teach you, if I'm teaching you, I don't know, Pythagoras, do I give you hard Pythagoras questions straight up?
Mm-hmm.
No, I'll give you easy one to start off with, right? Let me actually share the document. Where is it? Did I not send on Discord? I didn't. Like the first question you'll see is easy because I want you to focus on the very basic 2 to 3 things. Then I'll give you harder questions. It might be a 4th thing you're being tested. Why is it not sending? Yeah, I start with the easy concepts first, right? That's following the principle because learning is about slowly building it up, right? And that's where this error log's really good because you can build it up using the error log. Does that make sense? Now, the reason it's important now is because, well, yeah, last topic, some of you might have already done it in school and you'll be like, oh, it's okay. I can handle everything. Some of you might have not done it. That's fine as well, right? But now onwards, it's getting harder and harder. You're going to learn more concepts that you probably all of you have never seen before, right? Who's done like distance and midpoints before?
Is
Distance?
that like A and B and C is like in the middle or something?
Midpoint, yeah. Midpoint, I'm sure some of you done it, more of you done it. Distance is a little bit harder. If you done distance, that's good. Right? So yeah, like this is, and that's the first topic in corner geometry, right? But it's hard, but it's you're only gonna learn if it's difficult, right? There's no point me teaching you easy things. What's the point? I'm only gonna learn if I give you challenging things, right? So don't think of challenge as bad. And I've given you these systems to work through challenges as well, right? Like the error log. Yes, summary sheets. I've given you one summary sheet so far, which is the inequalities one. Yeah, right. Which I'll give at the start of lesson every week. From next week, couldn't do it this week either. But yeah, we've got that's the standard recap as we did last year. Okay, and what else is there? Last week, everyone's in person, and then no new mic. I mean, not relevant to you guys again, because yes. So yeah, few additions to the online because I realized my audio is terrible. But yeah. All right, let's get started. Let's start with the summary sheet, which I need to find here. Sorry, give me a second, everyone. Sorry, I've added a lot of things to the class, and I just forget some of them. I need to create a system. So,
like you did when you keep forgetting to record.
Yes. I'm definitely gonna come up with a system today, so like to have what I need to print out every day. But okay, you see linear inequalities now. All right, perfect. You can start with 10 minutes, about 10 minutes, doing a recap of linear inequalities. Now, how confident is everyone with linear inequalities? That's good. All right, so the thing with linear inequalities, first things, these are the key notations. For 4 of these. Let me actually cover these. You can see it, but okay. These 4 linear inequalities mean, these are the meanings, right? The one with the mouth open to the left, right? The way I think of it is like a mouth. Whatever side the mouth opens to is the bigger side. I don't know why, but right? Like this said, the mouth opens to the left, so the number to the left is bigger. So you say 2 greater than 1 or something. And this on the other side, this is the smaller side on the left. So you say 2 smaller than 3. And then the equal sign just means you can have inequality. So it's the same as the less than sign, or the greater than sign, but you can also be equal. So like everything that fits this also fits this, but on top of that, you also have the equal case. And that's basically the difference, right? So you can say 2 is bigger than or equal to 1, but you can also say 2 is bigger than or equal to 2. Makes sense? That's the exception, right? The equal case. So not an exception. That's like the one addition. And then you can go to the exception for solving linear inequalities, because the way you solve linear inequalities is identical to how you solve linear equations, with the one exception, which was when you divide or multiply by a negative number, right? When you divide or multiply by a negative number, you need to flip the inequality, right? If it's greater than, it becomes less than. If it's less than, it becomes greater than. If it's greater than or equal to, it becomes less than or equal to, and so on, right? And that's basically the key idea. So here's an example, right? If you have negative 2x is bigger than 6, you divide both sides by negative 2. That's the standard algebra step. And the only sort of difference is, basically an equation, except this flips from, right? From here to here, this flips. Make sense? And the same for multiplication. Here we multiply both sides by negative 3, and then the inequality flips. And here's an example problem, right? If you have 2x minus 5 is bigger than x plus 3 times 1 plus x, you just solve it like the linear equation until this step here, right? Like this is expanding brackets here. This is collecting like terms. This is bringing the constants to the right. This is bringing the variables to the left. And then this is the special step. What happens there? Sorry? Flip. Because what do you multiply? Yep, divide by negative 2 because you have a negative 2x here. And that's the only thing. So it's not really new, right? Pretty easy because you're using knowledge you've already had before, right? Because most of it's what you've had before, except there's one exception. Now let's do one example problem. And let me come up with one. Just get one off here. Let's do this one. 1 minus 7. I'll be mean. I'll do 2. You get 5 minutes to solve one of them, but if you finish early, you get a spare one. By the way, did you guys do questions from the worksheet?
The worksheet.
So not just the alchemist, the worksheet as well. So I didn't say any specific. Did I say specific question? I might have. Yeah, I'm still trying to figure out how to set questions for that, but I'll try to get a bit better at that. But yeah, here's the 2 examples. Some of you might have done this. So let me check. Oh, sorry. To see the homework questions. You might have done I, but it's okay. It's hard. You can do it again. Remember, same as an equation, except for that one exception, right? And if you make a mistake during this section, just start the log of the error. Don't finish it because you don't have time for that. But just start it and finish it during the problem solving part. Quick, I'll put 3-4 minutes. And if you need to refer to the summary sheet, feel free to do that. Again, you only need to finish one of them, but if you finish early, there's part I as well. Right? I'm only really giving time for one, but I know some of you are quick. Very close on part H. Very, very close. Remember, every time you multiply by negative, you gotta flip. Every single time, without exception. You flipped it once. Which right on top. But identify the error first. Do you see the mistake there? Just go through each step and see. No, you can. You don't have to. If you want, we can redo it, but just you can read through it and try to see. What's the operation? Add it, subtract it. But is it subtraction? Because what does this mean?
Oh, divide.
It's already divided.
Oh.
So remember, it's opposite.
Okay.
Note it down there for now.
Already or
Never finished it, but it's on the right side. Is also good. That's not equal to. It's greater than or equal to. Wait, but that's on the other. Wait, that's correct. But that's correct. But remember, you gotta get x.
yeah, and then you
Equal sign.
so wait.
Equal to 0, right? Also, don't write steps like this. If you want to do it that way, I recommend doing it like this. Like the arrow leading. This is the first step, the second step.
Oh.
So it's not equal. Second one, I have not checked. I'll check that straight. Very close on H. Extremely close. Let me tell you which line this step is. This step. Yeah. It's noted on the arrow as well. Don't fill it in yet because again, you don't have time, but note down what the arrow is so that you can come back and fill it later. Note down the arrow. Just so that I know it's the mistake, right? But it's a habit, right? You want to break the habit, and ignoring it's not the way to have it. So just write down. Just do the first two columns, the question and then the mistake type. You can do the fix later. We'll go to the problem section. Even identifying the mistakes is important. What was the mistake there? Yep. You switched once there, but you forgot to switch on the other one as well. But it's important they switched every time. Because you're probably used to seeing switching only at the end, right? Wait, switching, it doesn't matter if it's at the end of the front. You always do the switch. Do you see how you slowly pick up these things by identifying mistakes instead of trying to learn everything at once? Because if I try to teach you all those things, when I teach it, it's just too much. And your brain, I'm not going to teach well, and you're probably going to struggle to handle all that information. But yes, let's go. All right, so here's how you approach this question. You have 1 minus 7x divided by negative 2 is greater than or equal to 10. You multiply both. You have this divide by -2. You want to get rid of that. You don't like fractions. So you multiply both sides by -2. When you do that, this fraction goes away and it becomes 1 minus 7x, right? And this becomes greater than or equal to, sorry, not greater than. Because it's multiplied by negative, it switches to less than or equal to 10 times -2 is -20, right? And then we want to bring the 1 to the other side because that's where the constants are. So let's subtract 1 from both sides. You end up with -7x is less than or equal to -21. And then here we divide both sides by -7. If you want, you can do it in 2 steps, but I think at this point, you guys can handle doing both at once, right? 2 steps would be get rid of the negative first, like multiply by -1, then divide by 7, right? But you can just do it in one go. So -7x divided by -7x, but it's divided by negative, so you flip the inequality. -21 divided by -7 is 3. Make sense? Because x is greater than or equal to 3. Any mistakes, log it, right? Even if it's tiny, just start logging. You don't have to complete it, right? I mean, if you've got through it, that's good, but we will move on. I'll quickly do this. I won't explain it. I'll just write it so you can compare. The equal sign. If you want to do this instead. I might have made a mistake. Oh, yeah, I did. -4. So 160 got? Quarter. Oh, yes, because you need to minus negative. So like minus plus. Yeah. It's a common mistake. That's literally the one I have in the example. Happens all the time. Right? That's the example. Yeah, right? That's this mistake. The one I've written down here. But I'll confirm the answer quickly as well with the textbook because I just want to make sure I rushed it. Oh, which one is it? 1E is inequalities. 1E question. 1E where what's 2I? Yes, x is bigger than 1/6. Yeah. Other than that is good. But just log that error, right? Just so that you can slowly fix those things. All right. That's the recap for linear inequalities. Any questions about that? All right. You guys feel a little more confident about it now?
Mm-hmm.
All right, good. Because yeah, even from what I saw, it looked a lot better today. It's really good, right? That means you guys are doing the homework a lot, which I really like, right? Okay. Now corner geometry. What I do want to do is screenshot this. I will come back to this. Tutoring. You guys prefer the dark background or the lighter background? Dark background. I don't like the grids. Let me get rid of this. So coordinate geometry. I know a couple of you have done it, so that means it's new for most people here, right? But to be honest, this is a really, really important topic because visualizing algebra is probably one of the most powerful problem-solving tools, right? So if you can think visually about algebra, which is what coordinate geometry is about, it's really, really powerful. So in coordinate geometry, what's happening is basically it's combining algebra and geometry. So back in the day, geometry used to be, like the Greeks, Pythagoras. He came up with the Pythagoras theorem. They loved geometry really back in the day, right? And it's sort of the big thing. But then, maybe in the, 1200s-ish, algebra became king. Algebra became, what everyone who was good at, all the mathematicians were like, algebra is the most important thing. That's when, But then, this guy called Descartes, I think, we'll come back to him later. This guy called Descartes came up with coordinate geometry, which is combining algebra and geometry, sort of like the two most important parts of maths together. And because he came up with it, the Cartesian plane is named after him. Descartes, Cartesian. Right? And that's the first thing we'll learn about today. But before that, we'll jump into a quick recap of Pythag because we'll need that for later. Okay, on your worksheet, if you go down to like the middle of it, page 6 or 5, page 5, right? On your worksheet, you'll probably see some Pythag questions. But who still remembers Pythag? What's the Pythagoras formula? Or Pythagoras theorem? Spot on, right? But that's just the formula. This is the formula you probably, the famous or the infamous formula. A squared plus B squared is C squared. But, if you don't know what it means, it's just a bunch of random letters. So what does it mean? What it means is for a right angle triangle only, right? The length of the two sides, two legs, right?
Oh, equals to
the sum of the square of the two legs is equal to the square of the hypotenuse. Now, what is a leg and what is a hypotenuse?
The hypotenuse is the other side, like the longest opposite.
The longest side?
And the legs
but I like that definition better. The one opposite the right angle. That's how it's defined. The fact that it's the longest side comes, it's like a property. Like a square is known for having, oh no, that's not correct. I don't know. What's another thing that's like, do you see, I'll come up with an example later, but do you see the difference between a property and a definition, right? The definition is the side opposite the right angle. But because of that, it's a longer side. So it sort of is part of the definition, but I think where it came about originally was the side opposite the right triangle. But you're not wrong. Don't get me wrong, right? You're not wrong to say the longer side because it's correct. But I think it's better to think of it because it came about because of that, right? But yes, what it's saying is the side opposite is C. That's the important thing. Color. It doesn't matter what the other two are, right? A and B can switch around. It doesn't matter because when you square them and add them, this could be A, this could be B. Who cares, right? Because the formula will still be the same. Do you see how the formula is equivalent if you switch these two? Because remember, you're squaring and summing. So it doesn't matter which one is A, which one's B. It matters which one's C, absolutely. But yeah, that's where the Pythagoras theorem comes from. Now, proofs for this are a bit unnecessary at the moment, I think, especially for recap. I might do, if we recap Pythag again a bit later on, once we've done quadratics, I'll definitely go over the proof, but I don't think it's worth our time. at the
When are
moment.
we going to be doing quadratics?
So this one's coordinate geometry. Then we're going to do number theory. Then we do quadratics.
So 3 weeks.
No. 2 topics away. So topics could be 3 to 4 weeks each.
Oh.
Yeah. So coordinate geometry is at least 2 weeks. So that's how Pythag works, right? Let's do a practice example. So I'll give you an example. You don't need to do this. You can if you want. Let's break the habit of needing. Let's be nice to begin with. 3 and 4, right? This is the right triangle. You don't know what this side is. How do you find the missing side?
Oh.
You can call it x, by the way, if you want. If it's missing, you can give it any value. So say x or c, you can do whatever, right? C squared is 3 squared plus 4 squared. That's 9 plus 16, 25. And c squared is 25. That means c is 5. C squared. Yeah, it's not c is 25. C squared is 25. So that's the important thing about the Pythagorean theorem. Very common error. You do c is 25. That's fine, right? That's a common mistake. Just slowly, quickly, you can fix that quickly, right? You put that in the error log maybe as well. You don't need to just to. I know I said you have to do a drill for all of them. You don't have to. I think if you can do for 3 of them at most, that's enough. You can't improve everything at once. But yeah, c is 5, right? But yeah, the important thing is c squared is a squared plus b squared, not c. So the missing side is 5. And then you also get to do another one, let's say. Actually, that's enough for now. We'll come to some different examples later. Let's do, yeah, so that's the Pythagoras formula. It says a squared plus b squared is c squared, not c. Okay? Any questions about that? And another thing, it only applies to right angle triangles. If it's not right angle, it doesn't work. Okay, yeah, let's go to some examples for you guys to do. If you go to the worksheet, you should have some examples. Page 5 of the worksheet. I'll give you 5 minutes to do both of them.
Is it page 5?
Also, your answers can be surds. Who's not familiar with surds?
Surds.
Like root 37.
Oh, okay.
So that's something I'll give you now. If you're not familiar with surds, I'll show you how to do surds in an example here. It's a bit different. Let's say this is 3 and 5. You want to find the missing side, right? You say x squared is 3 squared plus 5 squared, right? Then you go 9 plus 25. X squared is 34. Now, before we had 25, and 25 is a perfect square, so you know x is 5. But with x squared is 34, is there a nice number that you know that squares to 34? You don't, right? So what you do in that case is you leave it as a surd, as the square root of 34. And that is all you need to do. Now with square roots, there is one exception, which is if you had, 4 and 6 squared. That's a different one, right? Oh no, that's one you have. I'll get to that point later. You can leave it as surd for now. That's enough. right? So if it's not a perfect square, you can leave it as a set. And I put a 5-minute timer on. Both of them. If you finish, do question 2.
I want 20 and 750.
If it's big, it's probably not going to need to calculate the square.
Huh? Wait. If it's big, you don't need to calculate.
No, I'm saying there's probably some way to avoid calculating. That's what makes the problem hard. It's not making you calculate 210 squared and 750 squared.
Do you have to simplify, like, divide by 10?
Maybe not.
Okay.
Try it.
Wait.
So here's the one I want to talk about. That's this one. So root 52, that's the exception, where if it's this is correct, but since you usually want in simplest form. But simplest form means you get rid of any factors of this that are square numbers. No any factors here that are square numbers. You can start from a small one. Do it. Has everyone done part A? Question 1, part A? Did you get to root 52? Or simplified it even further yet?
Am I on the right track?
Very good. Everyone's done it correctly except they haven't simplified the set, which I'll talk about now. Right? Wait, root 52 again is correct. But it's a good habit to build to simplify sets.
Can I use my calculator for this one or no?
No, this one you can do without calculator. The 7, the 20.
Yeah, but then the 25.
You can do that.
25. I want to do it.
Long multiplication. Improve your mental maths. All right. Yeah, so you do Pythag here in part A. And you get x squared is 4 squared plus 6 squared, which is 16 plus 36, which is 52. That means x is root 52, right? But we always like to simplify our sets. And did anyone get the answer once you simplify the set? Not sure? All right, so the way you do it is this. It's a little tricky. Try to identify all the factors in here of 52 that are squares. So you can break, if you're not sure, you can just on the side break it down. What are some factors of 52?
Factors of 52.
Yeah, 2. And so broke down. And what is it? 26.
Mm-hmm.
Break it down even more. 2 and
13.
It's 2 squared times 13 is a prime factorization. You see the square then? 2 squared. So this is square root of 2 squared times 13. And what you can do is you can split this up. It's root 2 squared times root 13. What's root 2 squared?
2.
2, right? Like it's the square of 2. What's the root of the square of 2?
Oh, wait.
Square root means, this is what square root says, right? Square root of x means which number do I square to get to x? So if it's square root of 2 squared, which number do I square to get to 2 squared? 2. Make sense? So it's 2 root 13. Now, once you become comfortable at noticing square factors immediately, like if you notice there's a 4 in there immediately, you can do it straight up. I don't do all these steps, right? The way I think is 52. 4 is a multiple of 52. That means I can get rid of that 4. 4 is 2 squared. So it's 2. I can factor out. So it's 2. What's left over? 52 over 4. That's 13. So it's 2 root 13. So you can skip some of these steps. Make sense? You don't have to do this every time. But at the start, you can do it slowly like this. This might be something especially important for the logbook because we're not going to.
Do we have to do it if we get something that's not be able to square root?
No, so for instance, in root 34, we can't.
Yeah, so like, since we can't do that, do we have to do the prime factorization?
No, you can leave it as here.
Okay.
Yeah. Although I just did the prime factorization to show you how to do it slowly, right? But once you become comfortable, you can do it in one go. I don't do all these steps, right? I go straight from here to here. But at the start, you might need to do a few other extra steps. Do you want me to show you exactly how I do it? The way I do it is I go x is root 52, right? And then I go, what's the square factor in there? I think 4 is a square factor, right? So I do 4 times, even this I skip, but I do 4 times 13. Let's say I do this. I don't skip it sometimes. And then I go 4, square root of 4 is 2. So it's 2 root 13. And then that's what I do. That's all I do. But yeah, makes sense. Now, there could be multiple square factors. So, you can get rid of the 2 and then you notice the number here still can be simplified further. So you can keep going down. Or if you want, you can identify the biggest one in one go. But yeah, again, those are things you can do once you're more comfortable. So again, it's easy to start with slowly and then speed up. Speeding up is not hard. All right, and part B. Important thing about part B. The missing side is not the hypotenuse. So it's not C. C is already here. So this is, like, let's say, I don't know, B or X. This could be B, let's say, right? Or A. So it's 5 squared plus B squared. That's 8 squared. Makes sense? Because B is not, should have had this here. But it's obvious that's a right angle triangle, right? So this is the big side. This is the long side. This is the hypotenuse. This side's shorter. So this plus this is 8 squared. Makes sense? So Pythag isn't just, this is slightly harder here. But Pythag not just solving for the hypotenuse. You can use Pythag to solve for every single side. Makes sense? All right. So 25 plus B squared is 64. And with algebra, how do we deal with this? We're trying to get B squared. And Suniti said the correct step, which is to minus 25 from both sides. Makes sense? It's like a linear, it's not linear, but the way you solve it's pretty similar to linear. So you do B squared is 64 minus 25, which is 39. And then you get B is root 39. Now if you check, there is no square factors here. So you can leave this as it is. And I think, generally speaking, if the two numbers don't have any common factors, it's pretty likely they don't have, you won't have to simplify the third. I can't guarantee that. I think. Oh no, yeah, there are some exceptions, but most of the time you won't need to. And then question 2, I'll quickly tell you the approach. If you try to calculate 210 squared and 750 squared, unfortunately, that's probably a bit too much. The key to notice is the ratios. look, you know how I showed you a 3, 4, 5 triangle before? There's also a 6, 8, 10 triangle. Where everything's just doubled. It's a similar triangle. So I know it's not that exactly, but the idea is the same. So Pythag also holds with the ratios. So the important thing here is that notice that this triangle with, I don't know, 750 and 210, right? Also has a much smaller, similar triangle with the same ratios. And the way you identify that is to notice what is a common factor here. What's the highest common factor here?
Highest common factor, 30.
30. If you calculate it, it's 30. Right? If you're not sure how to calculate the highest common factor, you can do prime factorization or Euclidean algorithm, but that one's pretty tricky.
That's like, I can't remember that.
You don't remember?
No,
Yeah.
even after the extra.
I did. I remember it was hard. Only reason I remember it, I only learned it properly in uni.
Uni?
I knew about it before, but I didn't bother learning it. So if you told me to do Euclidean algorithm in high school, I would have not known. So you don't need it. But yeah, you can figure it out some way, right? And it's 30. So if you divide everything by 30, it still be whole numbers. This is 7. This is 25. And use Pythag to figure out this missing side. So you get 7 squared plus x squared is 25. And let's say this is x, right? If this is x, what's this? It's similar. If the smaller one's x.
So then don't you just like find?
Yes. And what do I need? Sorry, I get x, right? What do I need to do to x to get to the actual length?
You need to like,
No, square root. X already has the square root done to it. But x is the side of the smaller triangle. I'm trying to get to like the proper triangle.
Oh,
I divided by 30 here.
Yeah, so you have to multiply by 30.
Multiply by 30. So it's 30x here. So whatever x I get.
Do we have to do that?
You don't have to do it that way. Yeah, you can just find x and then multiply by 30.
No, I mean, do we have to put it back to its original size?
Well, yeah, the question asks what's the length of the other leg. We don't care about this triangle. We use this triangle to get the properties about this triangle. So x times 30, that's 30x. Sorry. That's how you get to this, but we're going to solve for x.
I'm not doing
You can do it. 25 squared.
Oh, that's not.
Oh, not 25. My bad. 25 squared. I think I've got like up to 30 something squared memorized. We don't need that. 15.
30 squared memory. Yeah, okay.
But just because I've done long.
1024 is this like 2 to the power 10.
That's honestly memorization. That's not me calculating it. It's just I've done so many calculations, long multiplication. I've memorized so many of those.
We listen and we don't judge.
You are judging.
I did say anything.
Yeah, I'm not saying you need to memorize 25 squared, but the more you do, you memorize better. What's 25 squared?
600. Oh, no, it's 640.
625. Yeah, 625. And then so that means 49 plus x squared is 625. X squared is 625 minus 49, which is 576. And I'll let you use calculator here if you want. But
this one?
No, you can if you want. But we're gonna move on after this. But actually, I'll skip some steps. You can get to this. This is x is 24, right? If you check with the calculator or something, you get x is 24. It's a whole number. What's our answer then? If this is 24,
720.
you multiply by 30, and you get 720. Right? It's a pretty tricky question. You gotta work with this simple triangle, then you gotta work out to here. Because yeah, if you told me to do 750 squared and 210 squared, I'm like, I don't want to do that, right? Again, it's still not super nice, but it's not bad. I think you can handle it, right? 25 squared, 7 squared, sort of thing. But yeah, that's the idea there. So we're going pretty slowly, so
Is it break?
I had a lot of concepts I wanted to cover, but let's go just one more concept, then we'll finish and break. So we've covered the revision of Pythag, so we're ready to. Okay, so that's Pythag, right? Now you guys are aware of Pythag again. A bit more comfortable using it. So let's actually go to it. But the funny thing is, the topic I was revising it for, we're not actually going to cover today because we don't have time. That's distance. Distance is very similar to Pythag, but we'll cover that next week. But for now, let's just learn about the Cartesian plane. Right? Like I said before, Cartesian plane is after this guy, Descartes, or I don't know what his exact name is. Descartes. That's probably wrong, but that's what I said. Yes, it's probably some like fancy
It sounds like
European.
It sounds French.
French?
Because like they use like DES in front of like words.
Oh yeah.
And,
or like even Les
Miserables. And then they use the.
Yeah, true. Probably is French. Yeah. So yeah, some random French dude, right? He came up with the Cartesian plane. And this was really powerful because it allowed you to combine geometry with algebra. And the key thing about the Cartesian plane, actually, I'll give you a quick, is that it's very related to the number line. Now, you know what the number line is, right? You start, number line represents every single real number. Right? So 0, 1, 2, 3, -1, -2. It spans forever, right? And I know the numbers that are labeled are the whole numbers, but the number line doesn't cover just the whole numbers, right? In the gaps between the numbers, every single number, other number exists as well, right? For instance, 1.2 could be somewhere here. Pi could be somewhere here, like pi, 3.14. Right? It's somewhere there. And all these different numbers are in the number line. Does anyone know what's after 3.1415 in pi?
7.
9's one after. Something else before that.
7.
No, 7.
8.
I think it's 2.
3.15.
3.141529 something. I don't know. 7. 7.
7 is the lucky number.
But yeah, the number line covers every single number possible, right? And you've seen number lines a lot. We saw it in the inequalities, but you've seen that before that as well. What the Cartesian plane is basically two number lines. You have one here, and the other one is perpendicular. Okay, makes sense? And this horizontal one is called the x-axis. And the vertical number line is called the y-axis. And in fact, these two number lines meet at 0. So it's the x is 0 and the y is both 0 at this point. And it's called the origin because of that. Does that make sense? It's just, this is just definitions. So x is the horizontal, y is the vertical, and then this is the origin. Now, the important thing about having this is now we can label points, right? For instance, when the x value, let's say is 1, and the y value is 2, so 1 and 2, so it meets here. This point we can label as 1, 2. Now this is the powerful thing. This is where algebra comes in. This is a point in space. But by giving it a numerical value, you can use algebra. And we'll get to that later, but that's the important thing. The algebra bit comes by giving it coordinate labels.
Isn't it like those questions where they just give you like if x is one, no, if x is y or something, and then it just says something, 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 one. I don't know. I swear I've seen the kind of question. Because
You probably will see some of them later. I'm not sure exactly.
No, they gave those questions in some of the topics you get.
I don't think we've had Cartesian questions.
No.
Or maybe the simultaneous answers and simultaneous were coordinates. Because that's what it is. Actually, simultaneous, what it is two lines on the Cartesian. Oh, you can't see black on this. Two lines in the Cartesian plane intersecting. And that's what the solution we get is. And that the point is the solution. But we'll get to that later. But you see how there's geometric applications to the algebraic equations we solved? That's the important thing. All right, so yeah, first thing I want you to become comfortable with is a super easy skill, which is labeling points on the Cartesian plane. And the way you do it is, let's say you have a point 3, 2, is the left one is the x value. The right one is the y value. So what you do is, the x value is a horizontal thing, right? So you move right by the x value. So you move right by 3. 1, 2, 3. Get to 3. Then you move up by 2. 1, 2. So you get here. And the point is therefore here. That's just how it's defined, right? If it's xy, you move right by x units. Sorry, start at the origin, right? Start at the origin. Move right by x. And then move up by y. And now, here's one more thing before I give you some problems to solve on your own. What if it's -2, -1? What do you do? So you move right. Yeah. So if it's negative, instead of moving right, you move left. So you move left by 2. And the -1 means you go
down.
Negative. So -1 up is 1 down. So 1 down. So you end up here. So -2, -1 would be here. Make sense? It's quite simple starting points. But that will be our first skill. And that will be on your worksheet in page 1. And that will be everything for today in terms of concepts. So let's finish that question. It should take you about, I'll give you 3 minutes to that. So you only need to do example 1.1. But again, super easy. You can probably smash it out in like.
Can I just name like these A, B, and C, and D?
Yeah. In fact, I'll do the same. It's probably a really good idea. A, B, C, D. Yeah, you finished early.
No, wait. I kind of did the wrong one.
What do you mean?
I did example 1.2 and give them this Cartesian plan.
Then do example 1.1 but draw the Cartesian. I want to. That's why I put it there. I know it's annoying, but if you finish early, get some practice drawing the Cartesian plan.
Do you have a ruler I can follow?
I don't think so. Let me check. Sorry. If you want, this is terrible. And you can use this as a ruler, but it's free.
Let me check if I have something like that.
That's not bad. Yeah, should be fine. As long as you can draw a straight line with it. You're not measuring anything.
This is going to be so long.
Keep going. Let me take a look.
Second time I use my calculator.
And it's for drawing lines.
Mine was kind of.
Go to label. Sorry, have you labeled these? Like do label, give me that label for yourself and for me. Oh, you did these ones.
Yeah, I thought this was like. I was like, why is there no numbers here? Then I'll type.
I'll take a quick look at your.
Wait, can you draw the numbers for me?
What?
Because I'm not good at measuring.
It
This is
doesn't
going to
have to
be
be
like 1,
perfect.
2.
It doesn't have to be perfect. It doesn't have to be perfect.
Okay.
I don't like it either, but
Hold on. Wait,
it's
what's
just
the
something
highest
you have to
number?
get used to drawing the Cartesian.
Right, the highest number is 4.
Oh,
so
that's super neat. That's fine as well. I do that.
I don't get how some people like to do.
Oh, okay. So you gotta. It's opposite. A is the x value, so you go right by 0, you go up by 3. You've inverted the two now.
Oh, great. I messed up.
So it's here. But it's 0, 5. I think you labeled it correct, but you labeled, I can see that's by elimination, that's has to be correct.
Yeah, do you see this? Giants?
It's just, I know it's annoying, and I feel you because I hated drawing this as well. But
As long as I don't have to do the little squares all the time.
just have to do it. You know? All right, that's a pretty good label. Yeah, we'll take a 5-minute break, and then we'll come back for some practice questions. Although they're pretty chill today because we only covered 2 topics. Why? Is it really neat?
No. Okay. Like you said before, girls have just got better handwriting. Better skills.
Probably. Also, we're lazy.
Yeah.
You measuring time? I already knew when I started.
What? 1 minute extra. Any other funny stories other than your distract and you calculating this?
Funny stories. I think I've told enough.
You need to tell more now since you've already kind of told us.
Any funny stories that happened to me?
Or embarrassing. We'll take embarrassing too.
I already said embarrassing. I'm really bad at Fortnite. I'm getting carried every single game.
No, that's not embarrassing. That's me too. So.
I don't know. How about you guys saying embarrassing stories? I feel like I've shared enough.
Skip.
We might learn something new after as well because we cover everything quick. How are you finding the topic so far?
Good.
Good. All right. One thing I do want to say during the next bit is that error log slowly filling up. Right? Not about the volume of questions you do. Every single mistake you've actually, you know what you should do at the start of the practice session? Answer, go through all the questions you did during the direct teaching part and try to see where your mistakes were and note them down. You don't need to do it now. It's fine. Like, take it easy for the next few minutes. But
Have you started playing tennis yet?
I play like for fun, but I don't want to play comp yet. Yeah.
I still have an injury.
Yeah.
This time I sprained my wrist.
No. Thing is, I'm kind of scared to play again because.
Why? I mean, like you just go and play. Like the first game, you're gonna be like nervous, but then you just.
Actually, yeah, I'm not that nervous about losing. I'm just more like it's 4 hours of my afternoon.
Oh, you got the afternoon.
Yeah, it's after this. I was meant to go play in Berwick today, but then luckily my friend who was meant to drop out said he can play, so I don't need to go.
You mean like take a bite?
No, so he said he's busy, and then the other guy also said he's busy. I'm the fourth player. And I was like, okay, I'll play. And then like he was like, oh, never mind, sorry, I'll play. Might be because I'm bad. But when I heard that, I was very happy.
Yeah.
Dude, yes. Apparently, last week, the doubles match went from 1 to 4:30.
1 to 4:30.
Doubles only.
3:30. 3 hours and 30.
Yeah, and then they played singles, and
what was the score?
Let me check.
Like 6, 7, 6.
I didn't bother checking. Let me check.
All right, I'm gonna guess 7-6 to your position, 6-3 to your team, and then 6-4.
It's super tight. Oh no, it is full set. Yeah, I forgot.
And then 7-6 to your team.
Saturday PM.
7-6, 6-3, 7.
Your Sunday morning? I'll play Sunday morning in. The worst feeling ever. We are 6th at the moment. That's probably why he doesn't want us to play. So
that's sad.
This is the last match. We got 8 points.
Yeah. Holy!
Oh, it's 2-6, 7-6, 7-6.
Wait, so you went to opposition first?
They play doubles first.
Oh, I was close to the same sixes last time.
Yeah. And then the guys retired in the...
Wait, your friends retired?
No, the other team retired.
Oh, yes.
They were cooked, apparently. They were like done. So they retired in the singles. So that's why they got a 6-0 in the second set.
Last week we played the 36-degree.
Oh no!
And it was windy on clay court, and I would put sunscreen on my face, and the sand was like getting
Oh no!
on my face. Yeah.
Do you play Waverly tennis as well?
Last week we had a home match. We had to play until like.
Wait, which grade do you play?
I played B special 4.
Let's see.
Oh no!
Let's see Niklesh's results.
I can tell you the results right now.
Okay, we can see. I want to see more details. B special 4.
Eastern region.
Yeah, I know.
Oh, which one? Which team are you?
I'm Notting Hill.
Oh, that club. I like that club.
Oh,
you guys won last week.
Yeah.
Oh, Niklesh.
Oh my God!
Nice.
That's my score. That's weird.
606. You actually did well. Good.
But the thing is, we had to play all the way from 8:30 in the morning to 12 in the afternoon.
Oh.
And it was like 40 degrees.
But you had chill matches. Oh, was the other guy?
Not chill matches. Like this guy, his dad just kept shouting out, "No, that serve was in, that ball was out."
Oh.
I actually hate parents who do that.
No. Dude, my friends have probably seen me play tennis like 3 times. They just like, they come to watch sometimes. But then I don't like it because I get nervous. I feel like I do worse when they're watching.
Oh no, why are you going into the other matches now?
Let's see.
Yeah.
Clash, you lost in a super tie break.
If you go to the like second last match, I cooked in the super tie break.
Let's see.
No, not the last match. Maybe it was a couple matches.
You did not cook there.
No.
Definitely didn't cook there either.
Uh-oh.
Hey. Oh yeah, you did cook here. Well done, Niklesh. What's your UTR?
It used to be 5, then dropped down to 3 because I lost to 3 UTR.
So you have a higher UTR than me. But my UTR is unranked now because I haven't played competition in more than 12 months.
What do you think it will be when you get back?
Mid 5s. I want to get up to 6. But I need to get more match play. But I also don't want to do much match play because it's 1 p.m. on Saturdays.
Then why don't you do like tournaments that are in the morning?
Yeah, I might do a flex league.
Flex league?
It's a UTR one.
Okay, I was like,
Yeah.
what's your stats?
It's just because like you like there's like a league of people and you contact them directly and you go, oh, when do you want to play? When do you want to play? And just play. So I can play in the mornings. I like playing in the mornings and evenings.
Can you show us the diss track, please? Please. If I pay you $10, will you show it?
I'll keep the suspense for a week at least.
Nah, please, no suspense. Please. Alright, if everyone says yes, you gotta do it.
No.
If everyone says no, you gotta do it.
No.
If you say no for not doing it, you have to do it.
Have what, sorry? Coles. What do I want to get? I think I want to get blueberries. Yes, I want to.
You're just randomly going into the shopping.
All right. That's the break. We went way over.
Just show us the diss track, please.
Yeah,
Please.
Maybe next week. I promise next week.
Promise. You promised. I won't.
I'm teaching you patience this week. That's a lesson.
Someone write it down in the notebook. And it's gotta be at the start of the class.
No, at the end of the lesson.
So we won't forget.
Sure.
Or you gotta show this to Rob too.
No, don't tell him off. All right, let's go into work again. All right, so this is the worksheet questions I want you to do. I want you to do the Pythag questions, but they're pretty easy. So just do a couple of them, and then you can move on.
Wait,
Yeah. Break was pretty late. Then we can do. It's actually not many. Just these two questions. You might learn something new after. We're gonna do some midpoint questions after. Yeah. But before that, do the error log. The order is error log, PyTag, and
What error?
you must have had a few. Take a look at your.
Ah, yes, this one. What did I do wrong?
Like all of it.
Just a couple. I'll say which one. Do at least 3. Doesn't matter as long as you have one of each type. That means you have one way you need to find the hypotenuse like this, and one way you need to find a leg. Actually, don't do this. This is easy. You've done this already. This one hypotenuse, one leg question at least. But do at least 3. All right.
What did I do wrong? That's not about this.
I think it's negative 5x.
Is it?
Sorry. It's on here somewhere. No, it's in the linear inequalities. I know. Here. Okay, so you have. You forgot the 4.
Hmm?
There's a -4 here.
This is -4?
-2, -2. They don't cancel. So this is two things, right? This is minus this whole thing.
Yeah.
And then, so you, keep going from here. So
So do I do this one or the ones that you've already said?
Identify errors first. So fix that. But do there's 2 errors, right? You're forgetting the minus the brackets, but then you also canceled out constants.
That's the error.
Yeah. Yeah.
Wait, this is linear inequality.
Yeah. I'm really happy that you guys are doing the error log. It's very important, right? I know it's not.
Wait, forgetting to minus the brackets, so.
You can, if you want, you can copy the first example. That's the exact. Copy only the first part. Oh, you can copy the whole thing.
The whole thing?
But then you have to do what the thing says then. That means you do a drill.
Like, I might just like point up, arrow up, arrow up.
But then you have to do the drill that they tell you.
I mean, well, do I have to do 5 with them?
Do 2 or 3.
Alright,
Okay.
But for the exam, like what chapter is the question?
For the first box, I think there's 2 topics. So it's linear inequalities. It doesn't matter what the question. Like you don't need to remember the question necessarily. If you want, you can write down some reference to it. Yeah. Oh, you can do question 2H in the worksheet. You can do Cambridge because that's 2H is enough. Then you'll know it's Cambridge. Because the other textbook it's not labeled the same way. There we go. You can skip this, by the way. And the next step part. So what can you do to fix that error in the future? So, by the way, this is 5 is too much. You can do like 2 or 3. You can create a drill. You can come up with, you can Google ideas if you want for later. But yeah, drill is important. Do you have some idea now? No, you can find research and figure it out later.
Wait, you went to Glenwood in the 18th. So what if I said Glenwood is 150?
I don't think so. It'll come up. When I search the channel and this track.
What's challenging?
That's where next week. That's learning patience is an important skill.
Patience may be a virtue, but I don't have that.
That's why I'm teaching it to you.
Wait, is it viral?
Ooh,
Let me check.
That's
1 million plus views.
Not viral. But let me check.
1 million plus views. And this is amazing.
Not viral. It's got 330 views. But, oh no. He also has a Logan Paul.
Do alt tab.
I deleted it.
Do command tab.
Nope.
Do command shift T.
No. I know what it is.
I was looking at the back of the screen. I was looking at the TV. I could sort of see it.
What is it?
I couldn't see anything. It was just a bunch of different colors, and then it was like black on the side, and then like sort of like
He also has a Logan Paul diss track. I just suck.
Can you go back to that again?
No. I promise, if you remember next week, you can see it.
But
I'm not embarrassed by it. I've seen it like.
then if you're not embarrassed by it, why are you so scared to show it?
I'm not scared of it. I just don't.
Yeah, so that means you're embarrassed of it.
Maybe I am, but you're still not gonna see it. By saying that. But I will show it next week. But not of my own volition. You need to remember.
Okay.
Let's hope you guys have a really busy week and you forget about this.
Oh no, I won't. I'm gonna post it on Discord. I'm gonna be like counting down the day. Watch.
Oh, also,
This was the busy week for me. Next week is not that busy. Oh, we might have to. Oh, we might see. We'll see. We'll see. Somebody else.
also give extra homework. Also, new condition. I won't give extra homework, but you gotta finish the homework. All of you.
Alright, so we all gotta finish the homework to see this. I'm fine with that.
You're good. Like you guys are way more productive now with the
The more embarrassing videos, the more productive.
Yeah.
If it doesn't exist, I swear I'm not gonna do the next homework class.
I'm not like that. It does exist. Imagine I'm just like randomly searching like typing like blueberries on coals.
Blueberries on coals, this track. Alright, so we only did 2 of these, right?
Yeah.
And then what do we do next?
The plotting questions.
The what?
Plotting.
Okay.
Page 2.
Page 2.
As we might not be able to do Kahoot today. My phone's not here. Who has a phone here?
I mean, I have a phone, but like no data and stuff.
Then how are we gonna play?
I mean, we could do like team ups or something.
2 phones for 5 people.
I mean, like.
Oh, we can do. We can get the.
Yeah, I can post it.
Oh yeah, my iPad. Okay, that's 4. That's pretty good. All right, we can do it. Right, in this case, this looks pretty chill. I might do another one.
Wait, this one?
Yep.
Do we have to do both of these, like this one and this one?
It's really
Yeah. And does each block count as like a one?
You can do 1. If you want, you can do 2, but I think
I'm
it might be too small. long thing is, it doesn't matter what you do, as long as it's a consistent scale. That one. Yeah, so the number squared is 5. Where is it 5?
So hard to see.
No, b squared is 5. A is good, b is good, that's good. You like 2 to 3 in that, and then ready to move on. Really, because Pythag is not the focus. The focus is this is just a recap.
Like, does anyone have a ruler?
Feeling a little greedy. I want to do another topic.
That just sounds like something my son would say. But like,
The recap went too long. Let's do one. Let's do another one.
then will we have something to Kahoot?
Yes, we'll go a little overtime for the Kahoot. Okay. So, because like just plotting points, it's just too easy. You need to do some math with the points. So that's the next one. When you can skip, you can do it homework or something.
Is it on the same one or do you draw one?
I think I'll prefer you to draw because drawing the card. Yeah. Fair. Okay, so guys, listen up. I'm happy with the questions you've done. Right. What we'll do now is we're just gonna cover some properties, and we will cover one of them only. And there's 2 properties. One of them is midpoint, which is, in my opinion, the easier one. One of them is distance. Distance is the one that's related to Pythag, but you know what? Let's do distance because we did Pythag already.
Indecisive.
Yes, indecisive. Okay, distance. So these are properties, actually, again, to reiterate, these are properties that relate to points, right? Properties that relate to points. So what we're doing, the first thing is distance between 2 points on the Cartesian plane. For instance, the distance between, it's just something super easy. 1, 2, let's say 4, 2, 4, 3. So this point's 4, 6, right? What's the distance between what? Let's call it A and B. What's the distance between A and B?
3.
3, right? It's 1, 2 to 4, 2. So you increase x by 2. So you move right by 3. Okay, perfect. What's the distance from B to C? C is 4, 6. You said 4? It's 4. You go up by 4 units. 2 to 6, right? 4. Now those are pretty easy, right? If you're only moving horizontally, if you're only moving vertically, distance is not bad. But what about here? A to C. Actually, I've not labeled C, but this is C.
3, 4.
What's the distance from A to C?
3, 4.
No, distance. That's how long it is.
Oh, 3, 4. Okay, pi that. So 5.
5. Do you see? You go right by 3 and up by 4. That means this is like a Pythagoras triangle. Distance is the length, the hypotenuse of this triangle. Make sense? And that is the idea. Pythagoras is the idea. Now, if you generalize this, right? If you generalize this to any 2 points, you can get a formula. This to black. Distance formula is actually, it looks kind of scary, but it's simple once I show to you. Is square root of x2 minus, actually I'll say before that, this distance between x1, y1, damn, that's bad handwriting, x1, y1, and x2, y2, right? Equals x2 minus x1 squared plus y2 minus y1 squared, and you square root the whole thing, right? Let's come to an example, right? Let's do these 2 points. Let's do 1, 2, and 4, 6, AC, right? This is an example.
So is that distance?
You see how it's going to work. Square root, right, of what's x2? What's the x of the second coordinate? If you're doing AC. Yeah. But I'll show you how it's related to Pythagoras. So x1 and y1 and x2, y2. This is the coordinate. So x2 means like the x coordinate of the second, x value of the second coordinate. What's the x value of C then? X, 4. So you do 4, you sub in 4. Yeah. I'm going to just rewrite the question better as well.
Is that like
square root of x2 minus x1 squared?
Could you zoom up, please?
Yeah, let me
Thank you.
make this a bit bigger. Too small. All right.
X. Is that a comma and then like a bracket?
x2 minus x1 squared plus y2 minus.
X1. Oh, 1. Okay, I thought there was a comma. 1 brackets equal to plus y. Okay.
The example I'm doing is the distance between A, which is 1 and 2, and B, which is 4 and 6. Right? And, oh, sorry, not B, C. Are you following the formula? You don't need to understand it, but you know what it means, right? So let's apply it to this, right? So what's x2? So this is the distance between x1, y1, that's the first coordinate, and x2, what? It's 4, right? So it's the x value of the second coordinate, minus x1, which is x value of the first coordinate, which is 1. Yeah, thank you, Nikki, that's correct. And Dravisha, what's y2? Not 5. Is the y value of the second coordinate. So these are 2 coordinates, 1, 2, and 4, 6. Y value of the second coordinate. Which one's the second coordinate? C, right? This one. What's the y value here?
It's kind of slow on the TV.
Oh, sorry. Is it lagging?
Yeah.
Oh. So this is the second coordinate. Oh no. That's 6. This is the y value. Make sense? I know I put you on the spot, but it's all right. Like, don't worry. We're learning here. Does it make sense? Like, I know the reason I'm doing that is because x1, y1, x2, y2 might be a little confusing for you guys. And it's fine to be confused. This is the first time you're learning with this type. Right? But yeah, do you understand what x1, y1, x2, y2 means? So this is x1, this is y1, this is x2, this is y2. So y2 is 6. What's y1? 2? Yeah. Sorry if I feel unspoken, but like you learn this way, right? It's all right. Like, and we're not judging if you're struggling with questions at all. Yeah.
So is this like the coordinates? So like
No, the coordinates are A and B.
Yeah, so that's A and B, right? So
Yeah.
like 1 and 2 and then
Yeah.
1.
Yeah, so you use the values from that. Yeah, exactly. And can someone tell me 4 minus 1 is 3 squared, 6 minus 2 is 4 squared, root 9 plus 16, which is root 25, which is 5. Exactly the same as we got geometrically. Make sense?
Oh, wait.
Sorry?
Okay.
Yes, it is a little more complicated, but
But then technically, what's the point? Oh, wait, never mind.
you don't have to draw every time. And you get used to it, it becomes chill. This formula, it's the same every time, no matter what the x and y are. That's what makes it better, I guess.
Have you seen the math scheme where it's just like when you're calculating something and a bunch of equations comes out?
Yeah.
It feels like we're after that stage now.
Yes, we're after that stage. But I want you to understand the form of equations. I'll quickly explain the equation. We will go over this next week as well. So if you're a little overwhelmed by this, it's okay. This is why this formula works. Right? Let's say we have x1, y1, and x2, y2. Right? And we want to find this distance between these two. But what we do, like to show it geometrically to prove it, the formula is literally do exactly what we did here. Break it up into the horizontal bit and the vertical bit because they're perpendicular, so you can use Pythagoras. Let's say this is x2, y1. This is like the fake middle point, fake coordinate you create to help you identify the horizontal part and the vertical part because they are, how do I say? They are, you can use Pythag when you know those parts. So what's this distance horizontally here?
By the way, the time's 11, so
After this water.
I'm just spending 5 minutes. Basically 10.
What's this distance here?
This distance.
Horizontal.
Horizontal. Wait, this. Okay. We don't know.
But in terms of the coordinates, you know?
1.
That's in this example, right? But with general coordinates. So this is the x coordinate, x2 here, and x1 is the x coordinate here. Using those values. Yeah, beautiful. That's correct. X2 minus x1 is the distance here. By the same logic, this is y2. Yeah, good. Now, the distance, right? Now, if we apply Pythag here, right? The distance squared
is x2.
Right. Yeah, spot on. And then you square root both sides to get distance because you got distance squared, right? That's your formula. Make sense? That's it. What's gonna, but it's 11. We'll make it big cleaner and
That
then put it
just
on.
looks like
We're getting to the stage.
I know. It just feels, it feels like we're like taking a course on maths now. Like
This is the year it got. I can feel it's getting real.
Really complex if you don't understand it.
Oh yeah, 100%.
It just looks
But
like
you do understand it, so that's a good thing.
It's like if you
But
watched an
okay,
episode.
if you don't understand it here, who doesn't understand it? Be honest. That's fine. We're gonna go over it properly next week. But yeah, I just wanted to give you an intro to that. If you can, try one of the examples at home. Memorize the formula for now. I'll explain the formula again properly next week. Right? Yeah, this will be brand new again. I will teach this again. Kahoot. If you want, up to you. You can do Kahoot, or if you want, I can explain to you. Is it Kahoot? That's fine.
It's like, I think I want.